So in my previous video, I was talking about the future value of money, and I showed you how to do compounding interest using the FV, or the future value function, in Excel. So if we click up here, we see what it's doing. We're giving the bank $1,000, so that is a negative amount because that's how much is leaving our pocket. The interest rate is 10%, and it's being calculated at the end of every year. So here is the math when I split it all out. The ending result was $1,331. So that is compounding interest, where you keep adding the original amount with the interest all the way to the end. Another way to do this is actually by saying, we could go like this and say 1 plus the interest rate, which is 0.1. This is the same as 10%. So 1 plus 0.1, put brackets around this to do this first, to the power of n, or 3, right? Three payment periods. So we go like that, which is the same as saying 1.1 times 1.1, one more time, by 1.1. And I'll just go into a cell here and we'll do the math. We'll say equals 1.1 times 1.1 times 1.1. And I'll just change the precision here, format cells, there it is, 1.331. So if I were to do this the other way, like this, with the exponent, I could actually type in equals. We'll do the addition first within the brackets, 1 plus 0.1, which is our interest rate, and then outside of that to the exponent 3. That gives us the same answer. And then we could, of course, substitute the hard-coded values in here, the 0.1 and the 3, with what we have, our actual values up here, because that's what it would look like in most Excel models. So I would come up here, just remove this part, and then say plus the value that I have in that cell, and then to the exponent 3, I would just say the value that I have in this cell, so that they could change dynamically. So here we have what you might see in a textbook, where you do the math first by adding, and then to the exponent 3. So I'm not a financial genius, but basically what we've got here, and let me just turn this on. What we've got is the equation like this. The future value of our money, so FV, and we're using that function in Excel, equals the present value multiplied by, go like this, and it's going to be 1 plus our interest rate, which is we call it I in this case, and then on the outside here we put to the exponent 3, so you can just put a 3 up here. So that is our equation. And as you know, we can substitute all the values, equals our $1,000 that we gave the bank, multiplied by, or they even remove this because when there's nothing there, the value outside is automatically multiplied by the result of all of this. But we'll just say 1 plus our interest rate of 10%, so here it's shown as a decimal, and then raised to the power of 3, the exponent 3. So then we get down to 1.1 like this, to the power of 3, and multiply by $1,000. So in the end, doing all of this, our future value, when we compound the interest, compounding interest, that's going to be our answer of $1,331.00. So this is compounding. I just want to be very clear about that. But what if it's just simple interest? So now let's look at simple interest. So now simple interest is, let's just get the pen turned on correctly here. When we don't compound, and it's the same amount each year multiplied by the interest rate. So it's a big difference. When we use simple interest, the amount we get back will be less. So if you ever had a choice, you'd always pick compounding. So simple interest, the equation would look like this. The future value equals the present value, so that $1,000, that's the same amount, just plus the interest. That would be the final amount. Now, how do we calculate the interest? Well, then we'll take it to the next step and say, okay, so we get our present value. We're going to add 1 plus the rate multiplied by the time. Simply like that. Okay? So now we're going to substitute in our values. $1,000 plus 1 plus the rate, which is 0.1, multiplied by the time, or the periods, which is 3. So we get all of this. So as you know, we do the multiplication first. 0.1 times 3 is 0.3. We're going to add a 1 to it, so 1 plus. So we're in the end we get $1,000 multiplied by 1.3. So we get 1,000. Let's just go like this: $1,300. So really, when you think about the equation, the major difference, let's just finish this off. So this is our future value with simple interest, and obviously this is less money. This is a little bit more. But looking at the equation, it all gets back to the equation. Here we are doing the multiplication first to get our decimal 3. Then we're adding a 1. But on this side, we do the addition first, and then this part is on the outside, and that's what makes this increase a little bit more. So breaking this down by all the different parts kind of helps you see what's happening inside of let me just click back here. Inside of this formula, I saw a video once and it was describing this all in about 20 seconds. And I thought, no way, there's got to be a better way to describe this to people. So you can do it like this, just putting in the numbers once you're comfortable with that. Or you can do the math like this for the compounding part, as long as you realize that this is compounding. And this is the way to do it with simple interest. Just that little difference of multiplying and then adding a 1. Over here, we are doing the addition first, and then we're multiplying it by itself 3 times. So the final thing I'll say is we're basically, the big difference is this number, 1.331, compared to the 1.3 over here. Just that little difference. And imagine if this wasn't just $1,000, it was many thousands of dollars. So in my next video, I'm just going to flip things around so that we're using, instead of using the future value, we'll use the present value.